equals to 3 to n equals to 7 state, you want to know if a photon was absorbed or emitted, and you want to draw an energy level diagram. So, energy diagram. So, to show energy diagram, we want to show the levels for an atom. So, you assume that your nucleus is here. And then you start from energy level 1, 2, 3, 4, 5. And I meant this to be all the same size. So if they're not, I don't know. So this is going to be n equals to 1, n equals to 2, n equals to 3, 4, 5, 6, in this case 7, so on and so forth. So energy level 1 is the closest energy level to the nucleus. Energy level 1 is your ground state. Ground state is the lowest energy state possible. So in the energy diagram, the y-axis is your energy axis. We don't necessarily draw this, but by definition, the vertical axis for all quantum is always your energy axis. So whatever is lower, that would be closest to the nucleus, lower energy, and as you get away from the nucleus, energy increases. Now, for this particular example, your photon goes from n equals to 3 to n equals to 7. How do I show the transition? Just like this. And from 3 to 7, meaning that initially it starts in energy level 3 and it ends in energy level 7. Now, by looking at the diagram, you can tell if the energy of this photon is increasing or decreasing. Do you think the energy of this photon is increasing or decreasing, going from n equals to 3 to 7?
Increasing.
It's increasing, but where does that energy come from?
Being absorbed.
Absorbed. So where does that energy come from again? It's absorbing. That's correct. So to go from n equals to 3 to n equals to 7, energy is absorbed. But do you think this happens spontaneously?
No.
Like we can have an atom sitting here and just... No? Then how does that happen? How do we do this?
Through electricity or...
You bombard this photon with a source of energy, usually with another nucleus, and it gets the energy and it moves up to the higher energy level. So depending on what transition you want this photon to have, you control the amount of energy that you give to this photon here. So energy is absorbed. Now this photon that's in energy level 7 has a very high energy. It's not all that stable. As long as I keep the source of energy, as long as I keep bombarding this photon and give it enough energy, it stays in energy level 7. But as soon as I stop that source of energy, or as soon as I don't provide enough energy, which is the delta E between n equals to 3 and n equals to 7, that photon up there is not stable anymore. And remember, in nature, we always look, everything goes towards more stability. So this photon, once it's up there in an excited state, because I gave it energy and it moved from the ground state, which was 3, to excited state 7, it's not going to be stable there. In order to get stable, what happens to photon? How does a photon become stable?
It returns back to its...
It returns back, very good. So in order to become stable and achieve a stability, this photon is going to drop back to a lower energy levels. It's going to be the most stable when it comes back to energy level 1. However, depending, if I cut off energy, maybe it drops back to energy level 1. But if I decrease the energy, it may drop back to other energy levels. Now, a couple of things to keep in mind. When this comes back to lower energy level, it is releasing energy. Releasing energy in a form of a radiation. So that's when wavelength and frequency and everything comes into the picture. That's when energy becomes important. Now, one thing I want you to keep in mind is that when this photon drops to a lower energy state, this transition, which is called relaxation because it goes from a higher energy state to a lower energy state, could either happen in one step. In this case, from energy level 7, it dropped to energy level 1. Or it could happen in multiple steps. It could drop to 6, then from 6 to 4, from 4 to 2. And from each one of these relaxation, a different energy is released. Different energy meaning, look at HC over lambda, meaning that each transition has a different wavelength associated with it. Now these wavelengths, if they fall in the UV-Vis spectrum, that's how we see different colors from each transition. Now, when you get different types of radiation, microwave, X-ray, or whatever, the principle is that you excite your photon to a higher energy level, to enough energy level that from that relaxation, the energy is released, in the microwave region, or in the X-ray region, or in the radio frequency region. And the difference between all this radiation is the energy of this radiation, which is associated with the wavelength of these energies, of these transitions. Questions? Yes?
So like, for example, this one started off in the energy level 3, and then it went up to 7. Would its ground state be considered at 3, or what ground
If I started from 3, yes, because you don't know what you have. Yes, in this particular transition, energy level 3 is considered your ground state, and energy level 7 is your excited state.
So can you ever get that to even go lower?
What do you mean lower?
Yeah, like, so if its ground state is at 3, can we move it down to energy level 1 to try to...
So, two things. He's asking if we have, so I'm talking about exciting an electron and moving it up to higher energy levels. And your friend is asking, can we make it go to a lower energy level or not? It depends. Let's say that you put the electrons around the atoms, and one of your electrons end up in the 3rd energy level. That's where it goes. And this is the lowest energy level possible for that particular electron. So if I let it sit, I don't do anything with it, this electron in the 3rd energy level is not going to get excited, it's not going to relax either. That's where it is stable. But let's say I have only one electron. The best place, the lowest energy state for that one electron is in energy state 1. Now, in order to get it to energy state 3, I have to excite it. If that's that one electron, as soon as you stop providing energy, it will fall back to energy level 1. But if in a ground state, meaning the most stable state, this electron, photon, happens to be in the 3rd energy level, it will stay there. It is stable. So we can't fit everything, all of our electrons and photons, in the 1st energy level. As you have more electrons, you have to fill up the energy levels, and sometimes maybe energy level 7 for a particular element, that would be stable state for the electrons that go in there.
Is that when we do kind of like calculations too, when it's like 1s, 2s, 3s?
That's the orbitals, and that's when we decide, yes, how many electrons we can fit inside each one of these levels. So energy level 1, we can only fit 2. But when you get to energy level 3, we can put 18 electrons in there. So all those 18 electrons, they will stay in energy level 3. 19th is going to go, in energy level 4. So it all depends. For a particular atom, what is the ground state for that particular element? Not in general. Any other question? Now, before I let you go, okay, can you pause this, please?